Okay, once again, in the denominator, there's also 2 terms. So you see, the thing is, when we have that established, then it means that in the simplification of this particular exponential expression, we are thinking in our heads, well, there's definitely going to be a type of factorization that I'm going to have to apply at some point. There is going to be a type of factorization I am going to have to apply at some point. And this is something that we need to get into the habit of understanding. The minute there's a plus and a minus sign in our fraction exponential expression, then it means some type of factorization is going to have to be applied. It's a different story, guys, when the relationship, all right, just like for instance in this problem that we had done like some few days ago. If you look at this particular problem, this one, all right, this one, here you can see that in your fraction, okay, so it's also one term, but in the numerator, how many terms are in the expression in the numerator? So here in the numerator, it's not 2 terms or 3, but it's 1, because the relationship between the bases is multiplication. In the denominator, there is 1 term because the relationship between the bases is multiplication. So here, there's no factorization that you are going to be applying. Rather, we are going to have to change the bases that you see from the the composite numbers. For instance, 2 is a prime number, so that's a prime base, that's fine. 25, we are going to have to change. 10, we are going to have to change. 8, we are going to have to change, and 5, we are going to have to change to its prime bases. Then after that, we apply the laws of exponents, law number 1 and 2, and 3 where it is necessary. All right, so remember, we can write this from root form to exponential form. Change this root, it becomes 25, and the x in the numerator, since it's a square root, 2 in the denominator. 10 can be rewritten to 2 times 5. And remember, guys, once you change the the composite numbers to prime bases, 25 is 5 squared, you put it in brackets. 10, 2 times 5 in brackets. 8, 2 to the power 3 in brackets. 5 and 2 are already prime bases, so that's fine. Then we apply law number 3. We distribute, we multiply the exponents. You see, 2 times x over 2. 2 to the power 1, you multiply 1 times x, 1 times negative 2. 5 to the power 1, you multiply 1, x, 1 minus 2. 2 to the power 3, 3 times x, 3 times negative 1. 5 to the power 2x, you see. Then from here, because you can see still that in the numerator, 1 term. In the denominator, 1 term. Multiplication is the relationship. So now you can apply law number 1 and 2 of exponents, because law number 3 has been applied successfully. Law number 1 and 2. You keep bases. Since this is in the numerator, x minus 2 plus another x minus 2, then when you go down, we remember that the signs of the exponent, they change. That's negative 3x plus 3, the collection of the exponents for base 2. Then you collect the exponents for base 5. Numerator positive, numerator same signs, denominator change of sign, negative 2x. Do you see that? Then you add and subtract the like terms, and you simplify, and you get the simplified answer. So when the relationship between your bases is one of multiplication and division, in your head there is no factorization that is going to be applied. You are simply changing your composite numbers to prime bases. Then you apply law number 3. Then you apply law number 1 and 2. You add and subtract like terms, you simplify, you get the answer, and you make sure your answer is in positive exponents. But guys, when between bases, the minute you see that there's a plus and a minus sign that is separating your bases, then in your head you are like, there must be some type of factorization I'm going to have to apply. But first, I split the bases according to their prime bases. These are already prime. So you split the base, as you see here, 2 to the power x times 2 to the power 1. 2 to the power x times 2 to the power negative 1. In the numerator, the type of factorization we are going to apply is we are going to take out the highest common factor. We cancel what is common. Obviously, in the denominator, we also split the bases, as you can see there. We cancel, we simplify what is left over, and then our answer, guys. Because remember, this 2 to the power negative 1 is half. 2 minus half over half. Then you use your calculator. 2 minus half is 3 over 2. This here line means divide, so you can put divide. Half is half. Then you remember that you can apply the KCF rule. You keep the first fraction, you change divide to multiply, you flip the fraction, and then you get the answer. Right? So the factorization applied here, because there's a minus sign in the mix, is highest common factor factorization. This here in this situation was a bit different, because here the type of factorization, the type of factorization we applied here was difference of two squares. So in number 4, is there a need to write step number 2? Okay, original question. Step number 1, splitting. Step number 2, yes, of course, taking out the common factor. Definitely. Because remember, when you have a plus and a minus between terms, all right, as I said, when there's a plus and a minus, it says to you there's a type of factorization you have to apply. So here, definitely, yes, the splitting part, definitely, definitely. You need to, because, yeah, for most learners, right, they don't see the common factor. And remember, sometimes some learners don't even take into consideration that is 2 to the. So it's better to show your splitting than to take out the common factor. All right, please, guys, very key, very important there. Because why do we split even here? It's because we can clearly see that there is no constant term. So that means there's no third term where we are going to be required to do any other type of factorization. Plus, we can see that base 2 for your different terms that has the variable x, the coefficient of x is the same. We have 1, you have 1. For the x, so you take out that common factor and then you simplify thereafter. Very important there. So guys, the minute we have plus and minus in our heads, definitely we know there's some type of factorization that is going to be applied. In this problem as well, we saw that the minute we change our composite bases, 4 is a composite base, 9 is a composite base. The minute we changed our composite bases to prime bases there, then we saw that, 2 to the power 2, then the n outside, 3 to the power 2, the m outside. Okay, now the splitting here, okay, there's no splitting that is required, but we can see that this is 2 to the power 2 times n can be rewritten as 2 to the power n to the power 2, because multiplication, the order in which you place numbers when you multiply, is basically unimportant. But what do we learn from writing 2 to the power n and the square outside? It means we have 2 of these 2 to the power n, and we have 2 of these 3 to the power m's. In the denominator, we cannot do anything to the expression. Then we apply, because remember, with factorization, guys, grade 11 learners, with factorization, the steps that you go through when you are factorizing is you first ask yourself, when you are looking at the terms, 1, is there a need to apply what we call the sign change rule? Okay, by sign change rule, all right, we are looking at the expression in the denominator. it is 3 to the power m minus 2 to the power n. When we look at the expression in the numerator, 2 to the power n is not on the left-hand side. 2 to the power n squared is on the left, but 2 to the power n itself is on the right. So the order 3 to the power m here is on the right, whereas 3 to the power m is on the left. We have a subtraction sign, so that means some type of factorization has to be applied here. Alright, so what we do then is we apply, if we can, what we call the sign chain rule. Guys, the sign chain rule is only applied if necessary. What is the purpose of the sign chain rule? The purpose of the sign chain rule is that if in the numerator we take out a negative sign, that allows me to change the order of these two terms. So all of a sudden, this 3 to the power m, I can write first 3 to the power m squared. If I take this negative sign back, what happens? Negative times this gives me back that negative 3 to the power m squared. Does that make sense? Also, this moves to the right side, because if I take the negative times this negative, I get this positive back. So this is what we call the sign change rule, and the purpose is so that these terms, the order that they are in, should be the same order that the bottom terms are in. That we can always do whenever there is a negative sign between two terms. We can apply the sign change rule if the purpose is to make the order of what is at the top the same order as what is at the bottom. Let me repeat this again. The sign change rule is a rule that we can apply. What do? We take out a negative sign where there are two terms where there's a minus sign in between. You can take out a negative sign. Then what do? You rearrange the order of the terms. So 3 to the power m squared is now your first term. 2 to the power n squared is now your second term in this expression. And by taking out that negative, do we change this expression? No. The expression is still the same, because if you take the negative and you multiply this, you get the negative 3 to the power m squared back. If you take this negative and you multiply with that negative, you get the 2 to the power n squared that is positive back, because the negative times the negative is a what? Is a positive. Then I'm sure you can see that inside this bracket, there is a type of factorization that can be applied. What type of factorization? What do we refer to this as? Dots. 3 to the power m squared minus 2 to the power n squared. What type of factorization is this? We call this type of factorization from this expression. Thank you, Motu. It's a difference, because minus means difference. 3 to the power m squared is a perfect square, and 2 to the power n squared is also a perfect square. So we call this a difference of two squares. So we open two brackets. We can then write this as 3 to the power m and 3 to the power m, because the multiplication of these two gives us back this. We put a plus sign and a minus sign, because minus means different signs. Then we put 2 to the power n and 2 to the power n, because there's two of them, and multiplying these two gives me back this. Alright, then I'm sure you can see now that opening these two brackets allows me, because now in the numerator I no longer have two terms. I have how many terms in the numerator? Because of the brackets, this makes it what? One term. And in the denominator, if I put a bracket around 3 to the power m minus 2 to the power n, that makes it one term. Now I can easily cancel what is common. Alright, so do you see why I had to apply the sign change rule? The whole purpose was so that I can factorize and then cancel what is common. And there we have it, guys. Our final answer is minus into 3 to the power m plus 2n. I then distribute the negative sign, and I get this as my answer. That is how we simplify that exponential expression. If you have questions, guys, please ask. Because like I said, this is a situation where we have a plus and a minus sign between the terms. So the minute we have a plus and a minus sign between the bases, that means there is some type of factorization that is going to have to be applied at some point. All right. But our responsibility is to make sure first that the bases are simplified, and then if here we can see, for instance, splitting, because the variable x has the same coefficient, we split, we take out the common fact. This here, in this case, we could see that, hey, the coefficient of the bases, of the variables, this is 2, okay, 2n, this is 2m. Different variables, but there's a difference. So that tells you that there's some type of factorization that's going to have to be applied, and it's a difference of 2 squares. If you know it, you know it. Okay. Then lastly, the problem I did the last time as well, which I concluded with, was this one. Okay. Now here again, what do you see in the fraction expression? The numerator and the denominator. How many terms are in the numerator? There are 1, 2, 3. 3 terms. In the denominator, 1, 2. So here, there seems to also then suggests to us that there is some type of factorization that is going to have to be applied. By who? By you. Okay? But firstly, 4 we can write as 2 to the power 2. Then the x is outside. We put it in brackets. Guys, whenever you change a composite number to a prime base, please always write it in brackets. And you see what I keep on doing here. And you say 25, 5 to the power 2, brackets, 8, 2 to the power 3, brackets. So that you can remember that if distribution is needed, you distribute. 4, 2 to the power 2, brackets, you see? Okay, so here we deliberately prime base 4 as 2 to the power 2. All right. If we rewrite it, we know this is how many. It's 2 to the power x raised to the power 2. How many 2 to the power x's? 2 of them. Okay. So once again, here we have something squared. The 2 to the power x here is squared. Let's move on to the second term. 3 times 2 to the power x. This is 3 times 2 to the power x. Okay. Minus 4. Minus 4. This here is a constant. So what we can see then here is that we have what we call a quadratic trinomial. Quadratic trinomial. All right. If you think about it this way, if you were to let 2 to the power x be equal to k, then it would mean here at the top you have k squared minus 3k minus 4. This, guys, I'm sure you know, is a trinomial. All right. How many 2 to the power x's? 2 of them. Minus 3 times 2. The base 2 has the variable x, but the exponent here is 2. The exponent here is 1. When we have a situation where one variable, the coefficient specifically, is twice the other one, guys, very important, is twice the other one. Like for instance, as you can see, base 2 for separate terms. The coefficient of x, one is twice the other. Then to you, if there is a constant as well, a constant number, then it means that for the 3 terms, this is a quadratic trinomial, as you know a quadratic trinomial is. So what type of factorization can we apply here? We can apply the factorization that you learned in grade 10 and in grade 9 when it comes to a trinomial such as this. So what you do is you open 2 brackets, the 2 to the power x squared, 2 to the power x times another 2 to the power x will give you this back. Then you ask yourselves, what are the factors of negative 4? When I multiply these factors, I must get -4. When I add these factors, I must get -3. I repeat, when I multiply these factors, you know this, guys, from factorization. If you have mastered your factorization in earlier grades, then this shouldn't be a problem. It should be easy, a walk in the park. So you are in grade 11 now. There shouldn't be any issues here. But if there still are, when you have time from today until school reopens to go and sort out your factorization issues. Because, guys, your factorization in grade 11 is key. All right. So just like here, when you factorize this, right, you would open two brackets, right? Write k and k. But remember, your k is represented by 2 to the power x. So it's 2 to the power x and 2 to the power x. All right. I know some people like letting k being equal to something, but guys, even if you don't go through this process, because some of you even forget if you let k, you forget to write your answer in terms of x. So familiarize yourself with just factorizing the expression. And yes, Vutu, the values, the factors are -4 and +1. When you multiply -4 and +1, you get -4. The multiplication must give you the last term. The addition must give you the coefficient. Remember, this is like your k. This is treated like a variable. This whole entire thing is like a variable. This here is the number multiplied to the whole entire variable. It's like k. Does that make sense? So that is why you only concerned about the constant and the number that is before the 2 to the power x. When you multiply, you must get -4. When we add, we must get -3. So you are right. It's -4 and +1. But what you notice now with what is in the bracket, with what is in the denominator, all you have to do now is put this in brackets so that it is one term. Cancellation can happen. That is your final answer. Okay, guys, I need you in your heads to separate problems that have multiply and divide. There is a way in which we do problems that have multiply and divide only. All right, and the way is we change our composite bases to prime bases. We apply law number 3. We apply law number 2 and 1. We simplify. All right. But the minute there is addition and subtraction, that needs to scream to you, there's a type of factorization that is going to have to be applied. Whether it is splitting and highest common factor that you are going to take out, or it is after prime base, changing your composite numbers to prime base, you are going to have to apply the sign change rule and difference of 2 squares it. Or you are going to have to apply trinomial, because the expression either in the numerator and the denominator is saying there's a quadratic trinomial. You need to be aware of when quadratic trinomial is to be applied. And simplification follows suit thereafter. So there are two camps here of simplification. There's the camp where you have multiplication and division alone. No factorization is done there. Rather, the method is clear. Then there's a camp where there's a plus and a minus sign in the numerator and the denominator. There is some sort of factorization that you are going to have to apply with those types of problems. So now, before I move on, can we sort of like say there's some sort of clarity in our heads? Because when you don't have that distinction of like the separate understanding that, okay, with multiply and divide only, I'm doing this. With multiply with divide, where there's a plus and a minus sign in the mix, I'm doing this. When you don't have that clear in your head, then what happens is you begin to do funny things where you shouldn't. It's like, let me just make an example. It is like, there is a difference between when you are eating an orange and when you are eating like grapes. difference between eating an orange and eating grapes. Guys, I would say that when you are doing problems with multiply and divide, it's like you are eating grapes, right? You are eating grapes. You know there's no factorization that's going to be needed. You are just grabbing the fruit, you are chucking it into your mouth, all right? But when there's plus and minus, yay, it's like you're eating an orange. You have to first peel off, you need to peel off what you are, before you eat the fruit. You don't just grab that fruit and you bite it. Doesn't work like that. So here we cannot apply, what we do here. All right. So let's be mindful of that when we are dealing with problems where we have exponential expressions and there's multiply and divide versus when there's addition and subtraction. So I'm going to pick it up then from here. Let's continue again then with today's problem. But I hope that recap assisted or assists the people that are in this live to know, okay, we do this here, we do that there. Okay, all right. Yeah. I think we can proceed to this problem. 3 to the power 2k minus 9 to the power k plus 1 over 4 times 9 to the power k plus 3 to the power 2k. So once again, we look at the exponential expression. What do we see? Numerator minus sign, denominator plus sign. So what does that say to you? We are about to eat an orange. All right. 3 is already prime with the variable. 9 is not prime. It is a composite base. So what are we going to do? We are going to have a chance to change the variables, to change the bases that have your variable exponents, k, all right? So this one is 3 to the power. Now, I like doing this because it gives me that sense of like, okay, there's 2 of these 3 to the power k's. Remember, guys, multiplication is commutative. Whether you say 2k or k times 2 doesn't really matter. But for me, it just reminds me there are 2 of these 3 to the power k's. Minus, now this 9, because there's a variable base, I'm going to change that 9 to 3 to the power what? 2. Then, of course, I put it in brackets, and then I make sure that my variable expression is outside. Over. Now some of you are going to say change the 4. I'm not going to change the 4. Why? Because the 4 does not have a variable exponent. The only things I'm interested in changing to prime base are the ones that have a variable exponent, because when I have to factorize, the focus is going to be on that primarily. Okay, so 4, I'm going to keep it as it is. Right. Maybe some of you will want to change it to 2 squared. Well, go ahead. But me, no, I don't. I'm not bothered about changing the 4. Okay. Let's do the game. Denominator 9x. There's no 9x here. This is k, my guy. This is k. All right. This is an exponent. Look, we call these are exponents. You see, now you are, let's go back. What do we call this thing? This is called a base. What do we call the m? We call it a exponent. Another word is index. All right. So this m is what we call an exponent or an index. All right. I did that in the first lesson that I did. First lesson. Guys, please go subscribe to my YouTube channel. All right. Some of you need to just become subscribers to my YouTube channel. The link is in my bio. All right. There's a playlist there for grade 11s that I've basically started ever since I started live lessons in December and now in January as we are continuing. All right. I took a very long time doing basics of exponents from grade 8 and 9 when I started the live lessons for the grade 11s. Why? Because the basics lay the foundation. Okay. Oh, okay, I see. Okay, my mistake. All right, thank you, Vutu. I really appreciate that. Sorry about that. Okay, the 9. Okay, my mistake, guys. Really sorry about that. So this 9 is a base. It's 4 times 9. My mistake, guys. Thank you for the correction there in the comment section. Thank you. It's a 9. I'm really sorry about writing it such that it looked like a exponent. My mistake. But thanks. I really appreciate you guys commenting in the comment section. This is the kind of, I guess you could say, interaction I like because, you know, yeah, thank you so much for that, bringing that up. All right. Morning, the grade 12s I usually deal with in the evening, but hey, I've been having network issues. Yesterday I was having serious network issues, you know, yeah. And with grade 12s, there's also a playlist that's on the YouTube channel, but with the grade 12s, we are currently doing functions because we did sequence and series and we completed it. Hey, but anyways, 9. So 9. 3 to the power 2, right? Plus 3 to the power 2. Okay. Now, let us go now and yes, let's go and do this. 3 to the power 2k minus 3 to the power. You distribute the 2 times the k, you get 2k. You distribute the 2 to the 1, you get 2. Over what, guys? 4 times 3 to the power 2k plus 3 to the power 2k. Now, from this situation, guys, right? I'm sure you can see in the numerator, base 3 has 2k as an exponent. Base 3 has also 2k. So that means here at the top, we are going to have some sort of factorization, but I'm sure you guys can see. So what we're going to do is we're going to split so that we are clear about what we see. Split. So already I can see highest common factor there. Very clear that it's highest common factor. Take out the common factor at the top, which is 3 to the power 2k. What are we left with? On the left, we are left with 1 here on this side. Minus what? 3 to the power 2. Over. As well, at the bottom, we have 3 to the power what? 2k. Left with 4 plus 1. Do you see this, guys? Yeah. So here at the top, 3 to the power 2k. All right. No problem, Mogwa. No problem. 3 to the power 2k is common. As you can see, there's a 3 to the power 2k for this term. There's a 3 to the power 2k for that term. So that says that we have a highest common factor, okay, that we take out. So let's take it out. We take that out. We are left with 1 minus 3 to the power 2. Go to the denominator. We take that out. 3 to the power 2k is common. We are left with 4 plus 1. Now, we don't have 2 terms anymore like we did here and there. We actually have 1 term. Why do we say 1 term? Because remember, brackets make it 1, right? That allows us now to cancel what is common. All right, we don't cancel across an addition and a subtraction sign. For instance, we can't cancel this 1 and this 1. Why? Because it's across an addition or a subtraction sign. We can't do that. Rather, we can cancel 3 to the power 2k and 3 to the power 2k. Why? Because they are having, both of them, a relationship of multiply with the bracket, and therefore the cancellation is allowed. Okay. Yeah, you can do that, Loche. You can do that. But I think what's important though is to make sure, okay, so this obviously I'm doing for teaching purposes, this thing of actually writing out each step. But of course, you'd have to first though make sure that the 9 is written, right, as a prime base, because your teacher needs to see that, the common factor is there. All right. Yeah, the common factor is there. Okay, remember the splitting thing we are emphasizing because certain learners, even though they can see there's a common factor, it's funny, man. I've seen this happen so many times. They'll take out a common factor, then maybe if they don't do the splitting, they'll say 1 minus 1 or something like that, because they don't take into consideration that this 3 is raised to the power 2 as a split term. So it's important to at least write split, then you take out the common factor. I personally encourage that because consistently it makes it makes it clear even for you and for the person who's marking you that, okay, you know what you are talking about. So at the top now we're left with 1 minus 9 over 4 plus 1, which is obviously negative 8 over 5. And that's that final answer, right? Done and dusted. So I don't know if Dagalo is like asking a question or he's just trolling and making unnecessary comments. It's people like that I actually don't really like joining the live lesson, because I think some of you are displaced, you come here and you just comment for the sake of commenting. I don't really appreciate that, to be honest. Yeah, I think when you have done live lessons for maths for a long time and you begin to see how some people act in the comment section, then you ask yourself, Dagalo, you say Dagalo, the K is 6 or 7, I don't know, no, it's 6,7 or 6,7, or maybe that's another royal trend that we are happening from people. All right, hope that was fine, straightforward, sweet, no problem, right? Okay, let's do the next one. The fifth root of x squared minus 5x to the power 1 over 5 plus 4 all over the fifth root, the fifth root of x minus 4. So here's a question here. This time round our bases are not numbers predominantly, rather we have variables as our bases. All right, and then we have rational exponents. All right, so the first thing obviously is we are going to rewrite, okay, because in the numerator how many terms? 1, 2, 3. In the denominator how many terms? 2 terms. So we know at some point some type of factorization is going to have to be applied, because we are now dealing with variables, and between the terms there's plus and minus. So the first thing, we need to change our root to exponential. So how do we change this root to exponential? Okay, do we still remember the rule that we apply? Still remember, guys? If we have a to the power m to the nth root, this can be rewritten as a to the power m over n. This is a very important, useful rule that we utilize. So of course then, as Dochi is saying in the comment section, we rewrite this fifth root, x squared, the fifth root of x squared, we can rewrite as x to the power 2 over 5. Very good. Minus 5x to the power 1 over 5 plus 4. So I'm sure you guys can already see what you're supposed to see, right? Write x to the power 1 over 5 minus 4. Okay. Then we can see this is a trinomial. it looks quadratic in nature because there's a constant, there's a coefficient with the x variable 1 over 5, 2 over 5. One exponent is twice the other. Guys, 1 over 5 plus 1 over 5 is what gives you 2 over 5. So if you multiply 1 over 5 by 2, you get this. So 1 is twice the other. So that means quadratic trinomial. So you can factorize. All right. So it's like if you were to rewrite this, this is like x to the power 1 over 5 squared minus 5x 1 over 5 plus 4 over x to the power 1 over 5 minus 4. And all I'm going to do is I'm going to put brackets around this. This cannot be factorized. This is not like a difference of 2 squares. Even though 4 is a perfect square, but 1 over 5, this does not make this variable a perfect square. Because, guys, remember, a variable, in order for it to be a perfect square, needs to be raised externally to a even number. Right? So x to the power 1 over 5, this is a perfect square. So that means with this trinomial, I'm going to go ahead and do what? Open 2 brackets, because this is a quadratic trinomial. Guys, are we getting this? Are we understanding? You see, so that's why I'm saying to you guys, the minute there's a plus and a minus, it kind of says to you there is some type of factorization. You need to think about the idea that there is some type of factorization that should be applied here. But that type of factorization, when you apply it, you should apply it, you know, in harmony with the rules of factorization that you have learned in the grades before. You did trinomial factorization, guys, now for how long? Like, this is literally, you are entering into your 3rd year of doing factorization. In grade 9, you did trinomial factorization. In grade 10, you did trinomial factorization. You are now in grade 11. You should be masters of trinomial factorization. If you are in grade 12 and you are still struggling with trinomial factorization, I don't know, like, what you are doing to yourself. Okay. So then, to get 2 of these, x to the power 1 over 5, x to the power 1 over 5. Do you see that? Then you want the factors. Plus means same signs. Same signs according to the sign of the middle term. So obviously you're thinking of 2 factors. When you multiply, you get positive 4. When you add, you get negative 5. So what are those factors and what are their signs? You see, that's very important. So that's why with the grade 10s, I've been saying in the platform that positive constant means same signs. Same signs according to what? According to the sign of the middle term. All right. Sign of the mother. So negative and a negative. And of course, as you've said, guys, there's 4 and 1. That has been factorized successfully. Not negative 4 and 1 over 2. It's negative 4 and negative 1. Plus as your constant means same signs. And these are the things that I mean exactly, that you are in grade 11 but you are still struggling with factorization. Your signs are still not, you know, they are not signing. Your signs are not signing, and you are making silly mistakes that are grade 9 and grade 10 based, and as a result there's no movement in your grade 11. There is no excellence in your grade 11 because you are still struggling, guys. You guys are still fundamentally struggling with basic things that you should now be masters in doing. All right, you have time, guys. If you are struggling with factorization, go and iron out this factorization thing. Alright, or maybe go and watch my grade 10 videos that I've been doing with grade 10 live lessons that I've been doing. There's a playlist there in my YouTube channel. You can go and watch that playlist on factorization, trinomial factorization, and go sort out your issues with factorization. So now you can see numerator, there's no longer 3 terms, there's 1 term. Denominator with the bracket around, there's 1 term. Cancellation is possible because you have common brackets. Final answer is x to the power 1 over 5 minus 1. Where? In the numerator. It's all over 1, but you can obviously, you know most. A number over 1 is actually that particular number. Okay? I hope that makes sense. Melad is such, but there's no shame in doing that exactly. If you want to upgrade after the number of years that you have, all it takes is your commitment, and I guess you are fueled by some sort of like change that you want to make in your life. So if you want to go ahead and do that, people have been doing it. I'm sure you've been seeing some of the testimonies and stories on social media and on these pages here on TikTok and so forth. People are doing it and they are changing their careers. So if you feel like you want to do it because you want to make a major shift in your life and career change, I go and do it. Okay. This person that's called Numinous, though you are saying I must do all these other topics that you are mentioning, when you can just contact me on the side, because it seems like you want specific help. All right. Yeah, and the thing is, I'm currently going through grade 11 term by term work. Thank you so much, Toki, for just clarifying that. I think Numinous must be joining me for the first time. But if you want assistance and help with other things, then basically when you have to contact me on the side. All right. Yeah, this is term by term work. So if you look at the syllabus for grade 11 for term 1, all right, schools have not started yet for grade 11s, unless there's special arrangements in certain schools for schools to have opened. But what I'm doing right now is I'm doing the term 1 work. So first topic is exponents and surds. That's what we are busy with now. Okay, next topic, equations and inequalities, and then the last topic, trigonometry. So unfortunately, you're not going to see me do that here. You matriculated last year. Oh, so you are just trolling then. You are trolling, most. If you are matriculated last year, when you are sorted and fine, you just want to sidetrack us. All right, let's come back here, guys. Look at this one now. Numerator, how many terms? 2. Denominator, how many terms? 2. What do we see? The base is a variable. That's the rational exponent for variable. So once again, we have a type of expression that we should clearly be able to see immediately in the numerator. What type of expression do we have in the numerator? Now, if you have eyes to see, you will have seen that, 2 over 3, 1 over 3, 2 times the other one. Thank you, Vutu. Difference, right, of 2 squares. Very good. So this 4x 2 over 3 minus 25 is a typical situation of difference of 2 squares. That's very important. So I can see then the 4x to the power 1 over 3 specifically for the x that is raised to the power 2. Okay, so that means 4 is a perfect square. X to the power 1 over 3 squared is a perfect square. Minus is a difference. 25 is a perfect square. Over 2x to the power 1 over 3 minus 5. So now I'm going to apply difference of 2 squares factorization. There's no need for sign change rule because you can see the order 4, 2, 25 at the end. So I know something is going to be happening with this bracket. So let's factorize using difference of 2 squares. We open 2 brackets. Right? We know most there's always going to be a plus and a minus sign immediately. What is the square root of 4? Then the x 1 over 3, 1 over 3. There's 2 of your x to the power 1 over 3. The multiplication of x's, you keep the base, you add the exponent. So 1 plus 3, 1 over 3 plus 1 over 3 gives you back the 2 over 3. Then what's the square root of 25? That's all over 2x to the power 1 over 3 minus 5. Common brackets? Yes. Common brackets indeed. We can see them. So those common brackets cancelled. What is left? A1 and a 1. but we know that a 1 in the denominator is not significant. It's different from a 1 in the numerator because that is significant. Step 3, why are we having a minus on the denominator when there was a plus? Why are you asking instead of saying, sir, you made a mistake? Thank you, Habib. That's what you should be doing. Telling me that, sir, you made an error. There was a plus sign. Why now all of a sudden? Why should you be writing such nonsense? You see? Yeah, because when you are sure of what you are saying, me, I'm, I don't know, losing my mind. Okay, so thank you for that correction, Habib. Thank you so much. Vutu, thank you for, I know you were asking the question because you just wanted to be kind. So thank you so much. I really appreciate that. Okay, confidence. Nice. I love it. Final answer. But hopefully as well, Vutu, this is to also show you that sometimes what happens when we are writing, we just change signs for no reason. You see this mistake that I just did where I just all of a sudden, I had a plus and all of a sudden, I don't know, for some reason, it changed to minus. Changes the whole entire situation. Do you see what I was cancelling now? Do you see what I was cancelling? And do you see what I wrote down as an answer? Okay, because of my error. All right, so of course there was a plus everywhere, so this is what I should have cancelled. This 2 to the power x to the power 1 over 3 minus 5 is the one that should have been left behind. All right, and that was my mistake. I'm very sorry about that. Okay, yeah, so let's not make the mistakes that I am making. The mistakes that I'm making, hopefully you guys will learn from them. All right, yeah, you are the ones that need to make sure that you are doing the right things. The correct methods are being followed, not what I do sometimes, which is errors that basically mess up the situation. Okay, are we good, guys? So we've looked at situations where between plus and minus the bases are numbers, right? But now in this situation the variables are the bases. Okay, still. Okay, Lee to love, what happened to minus 25? My dear, this we saw that when we look at the expression at the top, this is a difference, D. 4 is a perfect square. X to the power 1 over 3 squared is a perfect square. So the first term is what we call a square number. It's a square. 25 is also a perfect square. And by perfect square, guys, we mean those numbers that basically are formed by multiplying a natural number by itself. All right. So for instance, 4 is formed by 2 times 2. Hence you can see there's a 2 and there's a 2. Same numbers. That's what's beautiful about a perfect square. You form a perfect square by multiplying a certain number by itself. So 2 times 2 gives me back the 4. What happened to the 25? 25 is also a perfect square. It's formed by multiplying 5 by itself. So therefore I can put here as my last term 5 and 5 when I'm factorizing. Then of course, guys, to form a minus sign you need a plus and a minus sign. So that's why you put different signs in the bracket. Difference in your constant term means different signs in your bracket. Okay. So hopefully, Mli to love, if you still have a question about what you've asked, you will follow up with another question, or you will say you are okay in the comment section. Please, guys, confirm if there's something I've explained and you are okay. If you are still lost, then let me know. Please don't pretend as if you understand but you don't. Guys, you can, if you are pretending at school, then you can see why you don't get too far. Don't pretend here. Don't pretend like I am fine, I am good. Maybe people in the comment section to a large number are saying, yes, we are okay, we are fine. But when you're sitting there, you're like, ish. I don't even know what was happening there. You must be vulnerable and say, I don't understand, so that I can explain. Yeah, what I don't like is people allowing me to move to the next one and then they say, can you go back to that problem? I didn't understand what you said. You are killing me there. Jabulile. Unfortunately, that was... Okay, maybe let me just form another one then. Let's just do this. Let's just... Okay, yeah, I think that should be fine. Okay, let me just rewrite this, because 3x to the power 1 over 7 minus 7 over 49 minus 9 x to the power 2 over 7. All right, so I'm sure you guys can see this particular problem, this one. Okay, maybe let me just give you 4 minutes to attempt the problem, and then I will do it. Maybe you guys can do this one. Let me allow you guys to do this one. Okay, I repeat, it's 3x to the power 1 over 7 minus 7 over 49 minus 9x to the power 2 over 7. All right, 4 minutes, guys. Let me just give you some time to go over this. Do it. Time is 8:10. At 8:14, I'm going to do the correction. So you guys can attempt this and see if at least maybe there's something that what grade does it look like, Safer? Let's see if you guys are grade specific. You guys can see. Yes, it's you are guessing. Hopefully you can read there on the screen, because the sticker is there. Okay, well, I'm glad you can read. Great stuff. I'm pleased. That's amazing. Good job. You can read. It's official. Safer can read. Haha. Okay, I see your guys' answers in the comment section. You see them. We still got 2 minutes to go, guys. Actually, sorry, 1 minute to be exact. Kindly the first submission. Okay. All right, so let's look at this, guys. Let's look at it because the time is up. 4 minutes is up. Okay. So if we look at this, guys, 3 to the power x, 3x to the power 1 over 7 minus 7 over 49 minus 9x to the power 2 over 7. So once again, how many terms in the numerator? There are 2. Mushi grade 10 will be at 9 o'clock. How many terms in the expression in the numerator? 2. Expressions in the denominator? 2. So, in the numerator, is there any factorization? No. Okay, but for now, we'll put this in brackets. Go down to the denominator, 49 minus 9x to the power 2 over 7. So we have 49 minus 9, now the x. Okay, that's a perfect square, so we have a difference definitely of 2 perfect squares. And what I can see is that, yeah, x to the power 1 over 7 times 2 gives me this, so there's 2 of them. So really this is a perfect square. 49 is a perfect square. This is a difference 9, this is 1, x to the power 1 over 7. But if you look at the order, guys, something is off there about the order. So what I'm going to do is I'm going to apply the sign change rule. I'm going to apply my sign change rule so that I can address the problem with the order. Take out the negative 9. That allows me to then write 9 as positive and 49 as negative. Okay, so the sign in between is still there, but I'm just going to switch around. Okay, negative times that gives me that back. Negative times the negative 49 gives me back the positive 49. So really the sign change rule there, it worked. Then 3x to the power 1 over 7 minus 7 over, now we can factorize. We open 2 brackets. Remember 9 is a perfect square. 3 and 3 will help me out with that. X to the power 1 over 7. No, not in grade 9. Not with exponents in grade 9. Yeah. Then 49, remember, write plus and minus 7 and 7. Then you can see there's a common what? Common bracket. We can cancel. Remember, when we cancel this and that, we're left with 1 and 1. Remember, guys, in the numerator, when 1 is left alone, it is significant. 1 is significant in the numerator. So we have to say 1 over. Do you see this, guys? 1 over. Right? So it's very important that we understand that 1 in the numerator is significant. So the 1 remains. Unlike in this situation where we had cancellation, 1 was left in the denominator. And obviously, anything divided by 1 is that thing. So hence the final answer is 2 to the power x 1 over 3 minus 5. Okay? But here, the 1 is left over in the numerator. It is significant. So we need to leave that 1 in the numerator. Very important. Okay? So we have a negative 3x to the power 1 over 7 plus 7. So it's like negative 1 over 3 to the power x to the power 1 plus 7. Okay. If I decide to wake up and use the CSCR on the numerator, is not a crime. No, it's not even. Not even. If you use the sign change rule in the numerator, it's still going to lead fundamentally to the same answer, right? Yeah. Still gonna lead to the same answer. Still. Okay. Yeah. I hope it makes sense, guys. I hope this makes sense. So we have a negative 1 over 3 to the power x 1 over 7 plus 7 as our final answer. All right. Okay. Yeah, guys, I think with that said, I think we can move on from those types of questions. Okay, so that's just something to note there, that multiply and divide between bases. Okay, law number 3, 1 and 2 can be applied after we convert composite to prime bases. Right, law number 3, 2 and 1, and then we simplify. But if there's addition and subtraction between bases, guys, please, there's some type of in your head, it should jump that some type of factorization at some point is going to be applied, and therefore simplification is not going to be done the way that we usually approach simplification. Now let's move on, guys. I think we can move now from exponents and we can enter into the world of surds and roots. How do we simplify surds and roots of this nature? Right. Okay, so the question is square root of 50, square root of 18, square root of 8. Sorry, my bad. You want to have a peek back, please? Here's the peek back. There is the peek back. Okay. I hope your peek back has been sufficient because I need to move on. Vutu. Please indicate when the peek back has been complete so that I can move. Okay, thank you. All right, now we are there, surds and roots. Okay, all right. Now here we have numerical surds, square root of 50 minus square root of 18 plus square root of 8. Now here our objective is to write the numbers underneath the square root as a product of, now because guys the square root is the focus here, it means we are interested in writing those numbers as a product. Product means multiplication of a perfect square. This is borrowed from the idea that we are having square roots. Guys, if it was cube roots, then we would be interested in writing those numbers as a product of perfect cubes and another number. So what we need to do is, because we are given square roots, square root of 50, square root of 18, square root of 8, separated by plus and minus sign, we want to write all those numbers inside. Then numbers inside the square root, we need to write them as a product of a perfect square and another number. All right, because it's a square root. But if it was cube roots, guys, that we were dealing with, all right, then we would want to write the numbers underneath the cube root as a product of a perfect cube and another number. Right, now before I go into this, I want to just explain, guys, perfect squares in grade 8 you guys learned these are numbers that are formed by the multiplication of another number by itself. So for instance, if you take the natural number 1, if you multiply 1 by itself, what do you get? If you take the next natural number 2, if you multiply number 2 by itself, if you take the natural number 3, you multiply by itself, what do you get? All of these numbers that you are seeing here, these ones, these are perfect squares. 4 by itself, what do you get? 5 by itself, what do you get? And so it goes. You guys get the point, right? In grade what? In grade 8, you were exposed to what perfect squares are. And in actual fact, in grade 8, there was even this expectation that you needed to know all the perfect squares between 1 and 100. Okay, you needed to know them off by heart and know the accompanying numbers that are multiplied by themselves to get you those perfect squares. Those are perfect squares. Perfect cubes, on the other hand, if you multiply a number by itself this many times, okay, then what you get as an answer is a perfect cube. Guys, what is 2 times 2 times 2? this one I want to just ask, and then I would hope that you will have gotten the point. The difference between a perfect square number and a perfect cube. Okay. Hey, at least it seems that you guys are still okay, because I've seen funny things come from when I ask this question, 2 times 2 times 2. In the past, people have said many things. All right. Okay. So you guys get the point. Perfect cubes, if you take a natural number, you multiply it by itself this many times, that's what we call a perfect cube. All right. So please, guys, let's be familiar with such. So what I'm saying to you guys is that our whole purpose of this square root of 50, square root of 18, square root of 8, we want to write square root of 50, we want to write the 50, the 18, and the 8 as a product. Because we are dealing with square roots, we want a perfect square and another number to be the product inside the square roots. So 50, for instance, you guys tell me, what are the two numbers? I want a perfect square and another number that I multiply together to give me 50. Come on in the comment section. Let it rip, guys. Let it rip in the comment section. I know you know. Tlori, Sweet Face, Umdanzo, by the way. 25 and 2 years. Okay, so guys, we are good. We are good. We are good. Let's move. 18. You guys are 100% correct, by the way. I agree with you. Sweet Face, Ngutuku, Siso the Hustler. Yes, very good. 8. Lastly, 8. Yeah, thank you very much. You guys know. You guys know. So that means all of you, step number 1 will be fine. Let's just say there's someone in this platform that doesn't know such. Let's just say you didn't know. If you don't know, then go ahead, go to your calculator, press square root of 50. What do you get? You get 5 root 2, right? So that means this root 2 is going to stay inside. So all you need to do is just take this 5 and you square it. What is 5 squared, guys? It is 25. That will help you know the two numbers that you were supposed to have multiplied. You see? So if you don't know, go to your calculator, go and press it. You are going to get your answer in surd. We call this surd form, right? And then when because you didn't know the numbers that are multiplied, let's say you just don't know, then what you do is you take this 5, you square it, you get 25. So that means inside that square root there was supposed to be 25 and what? And 2. Same thing with 18. You don't know, Mosne. So you say 18, you press equal, you get 3 root 2. So what does that mean? You take the 3, you square it. What's 3 squared? It's 9. So inside the square root there was supposed to be 9 and 2. 8, you don't know it as well. What are the two numbers? You put the 8 inside, you say equal, you get 2 root 2. What was supposed to be inside the square root? You square 2, you get 4. So it was supposed to be 4 times 2. So guys, even if you don't know, you can always know. Now, of course, guys, this is just me trying to explain step by step. So of course, with multiplication inside the square root, we know we can write these separately. because the relationship of multiply allows us to separate the roots. There's a rule that says so. Even the relationship of divide allows us to split the roots. The only relationship that does not allow us to separate the roots is when we have a plus and a minus sign between the numbers. We don't ever separate the roots where that is concerned. Then you can work this out. What's the square root of 25? It's 5. What's the square root of 9? It's 3. What's the square root of 4? It's 2. Okay. Then last but not least, you look at these. 5 root 2 minus 3 root 2 plus 2 root 2. What is common? Root 2. So what does this mean? We can treat these as like terms. Okay, we can treat these as like terms. Why? Root 2 is like the variable. The numbers before are like our coefficients. Okay, so root 2 is like your variable. Okay, so what you do is you keep root 2, then you add and subtract the coefficients because you have the same root 2's. So what's 5 minus 3? It's 2. And then what's 2 plus 2? It's 4. This is your final answer. Okay. Now guys, let me just say for the record, the important steps here for the purpose of doing the problems is step 1. This one is an important step. This one is an important written step, and then the final answer. All right. There is no real need for this step. I just showed you this so that you can understand that when there's a multiply between your numbers inside the square root, you can, in essence, calculate the square root of 25, which is 5, the square root of 2, obviously the square root of 2, that square root remains over 2. Square root of 9, you can calculate. The square root of 2 remains. Square root of 4 is 2. For the square root of 2, it remains. Then you have like terms. You treat the root 2 as if it's a variable. You add and subtract the coefficients. 5 minus 3 is 2. 2 plus 2 is 4. This is your final answer. 4 root 2. And that's that. Essential steps. This one, that one, and this one. And guys, this here is an essential step, even though, let me say this on the record, when you look at your memo, if you are going to look at a memo with a question like this in a typical question paper, they show you this step. I mean, they show you the initial question, then they show you the step, and then the answer. Please guys, rather write the step so that the person who's marking can see that you understand the two numbers that you should be multiplying. Then write the step, then you conclude with this one. So that's why I'm saying these are the essential steps for the marks. Are we together? Are we together? Are we together? Are we together? All right, thank you. Tango, thank you. Okay, all right. Okay, let's move on. Next question. Square root of 12 times square root of 8 divided by square root of 6. Square root of 12 times square root of 8 divided by square root of 6. Relationship here is multiply and divide. Okay, so really here for this question, there is many ways to kill this cat. Many ways, because of the fact that we have multiply and divide as our relationship. So many ways to kill this cat. This we can write as a separation perfect square and another number. Even this one, perfect square and another number. But that one, you can't write as a perfect square and another number, because 6 can't be written as a perfect square and another number. Or we can multiply these two, all right, because they are both having a square root, all right? So really and truly, it's up to you how you go about approaching. But I'm just gonna do these questions using both approach. Chandler, you can send me a private DM. I'll respond to you. But I get that you're saying your daughter is doing grade 12. I do teach grade 12 too. You can send me a private message there. I'll respond to you. DM me, please. So 12. 4 times 3, of course. 4 times 2, of course. This I'm going to leave for now. Then here, 2 root 3. 2 root 2. Leave for now. All right. So some people could write it as 2 times 3 and then they separate, and then if you do that, right? Let's say we did this. I mean that also helps, makes life very easy, right? If you had written 2 times 3, then means we have 2 root 3 times 2 root 2 over root 2 times root 3. Now it's easy. All you do is you play. Cancellation game happens simply here, because what do you have, guys? When you have a relationship of multiply and divide alone, here you can just look root 2 va va, root 3 va va. What's left? Answer. Make sense? That's what's beautiful about when there's just multiply and divide. Cancellation happens freely, very freely. Okay, very freely, no stress, no nothing. So even initially from this step, you could have immediately said separate, right? 2 times 3, and then from here you go directly here, and then you are able to cancel. So you think about it, this root 3 and this root 3, goodbye. We are left with 1 and 1. This root 2 and that root 2, goodbye. We're left with 1 and 1. Then what is left at the top? 2 times 1 times 2. 2 times 1 times 2. Do you see that, guys? 2 times 1 times 2, which at the top is 4. Then 1 times 1 is 1. So obviously 4 divided by 1 is 4. Okay, so Ngotugo, I saw you immediately, were able to give me the answer. Mlungisi is asking, guys, maybe you guys can comment in the comment section and let Mlungisi know. Mlungisi is asking, Mlungisi 27, why 4 times 3, not 2 times 6? Do you want to answer Mlungisi? All right, I think we've already spoken about the fact that if we are dealing with a square root, what we want is to write the product of the numbers inside the square root as a perfect square number and another number. Okay, so 12, the factors of 12 that have a perfect square number and another number is going to be 4 and 3. 6 and 2, 6 is not a perfect square number, 2 is not a perfect square number. What is a perfect square number? We explained, for those that are joining only now, that a perfect square number is a number formed by multiplying another number by itself. So we say 1 is a perfect square. 4 is a perfect square because it's formed by multiplying 2 by itself. 9 is a perfect square number because it's formed by multiplying 3 by itself. 16 is a perfect square number because it's formed by multiplying 4 by itself, and so it goes. So that's why, for instance, with 12, we are very deliberate in the choice of numbers, factors that we choose. We don't choose 1 and 12. We don't choose 2 and 6. But we choose 4 and 3. 8, we don't choose 1 and 8. We choose 4 and 2 because this is a perfect square number, this is another number. Why are we going for perfect squares, guys? It's because there is a square root. The inverse of a square root is your perfect square. There's a square root. The inverse of a square root is a perfect square. So we have to have a perfect square and another number. For 6, we have no such combination of a perfect square and another number. So if we write 2 times 3, then we separate 2 and 3 to square root of 2 times square root of 3. At the end of the day, we are able to simplify to get a basic final answer. Okay? Yeah. Someone else who's doing this question could have decided that the square root of 12 times the square root of 8 over the square root of 6. Someone else could have decided to say the square root of 12 times 8 over the square root of 6. This is someone else doing the same question. Remember, these are split, but since it's the same root, you can write it under the same square root. This is the square root of 12 times the square root of 8. So if you are multiplying or dividing, you can write the numbers underneath the same square root, okay, over the square root of 6. So if we come here now, what's 12 times 8? Over what? Now the question, can you write this as a perfect square and another number? That is the $1 million question. Can you write 96 as a perfect square and another number? Is it possible? Exactly. All right, do you see that? So if you're going to rewrite it then as 16 times 6, then you know you have 4 root 6 over root 6. Those two cancel, you are left with 4. That's why I was saying to you guys that there's many ways to kill this particular what? Yeah, there's many ways to fry this one. All right, but this is the thing. When the relationship is multiply and divide, really and truly, there's there's many ways to maneuver. All right, but in essence, let's get the basics though. That the objective here is to simplify this thing so that at the end of the day we get the simplest answer. So whether you go this route or you go that route, and maybe someone else will say, "But sir, I saw this way." That's fine as well. Simplification, your steps. When I mark your particular problem, I need to see that indeed what you've applied is correct and you've done what is required. Okay, so various ways, ne? Various ways. Okay, let's move right along, guys. Let's move right along. And let's move right along. Simplify. Simplify 2 root 5. And then simplify this. Do you still remember, guys, what we do with when we have roots in the denominator? Someone is like saying in the comment section, but say, Aibo, this is already simplified. 2 root 5 over 5. 2 root 5 over 5. Okay, so you guys are right telling me the final answer. Very good. Guys, remember here we apply that process that we call rationalizing the denominator. the mathematical rule is that we can't ever have a root, or we can't have a surd in the denominator. So what we do then is we multiply by a unique special one. What 2 root 5 times 1, guys? What is 2 root 5 times 1? It is equal to 2 root 5. But what we do specifically is that the one that you are talking about is this one, a special one, which is the same denominator root 5, is being multiplied by as a fraction root 5 over root 5. Okay, so remember, for one term we multiply by the special one, and we get our direction as to what is in the denominator by what we see in the denominator of the root. If there is one term in the denominator, we multiply by that same root 5. But what we do at the bottom, we do at the top. So if you think about it, what is root 5 divided by root 5? It is 1. So this here, guys, is a special one that we multiply by. Okay? Yeah, guys, remember, we don't refer to this specifically as the conjugate. The conjugate, remember, only applies when there are two terms. All right? This here, we don't call the conjugate. Let's be careful about our wording. Okay, so this is a special one because I want you guys to know terms and to be able to understand terms for what they actually are. All right, so I don't refer to this as the conjugate. Okay, this is just the special one that is formed by multiplying by the same one term that is in the denominator, which is root 5. But what I do at the bottom denominator, I do at the top. Then root 5 over root 5 is actually equal to 1. Thank you, Shandlin. Then you say 2 times root 5 in the numerator. What's 2 times root 5? 2 root 5. Then in the denominator, what's root 5 times root 5? Guys, root 5 times root 5, remember we said you are putting both there. Since it's root 5 times root 5, these are both square roots. So that allows you to do what? To take the 5 and the 5 and put them inside the same root. What's root 5 times, what's the square root of 5 times 5? It is square root of 25, which is equal to 5. So in the denominator, I can write 5. That is my final answer. So that's why you guys said the answer is 2 root 5 over 5. What have we just done to the denominator? We rationalized it. Okay, so what we've done here, this is not the conjugate. Okay, please guys, this is just us multiplying by a special one. We don't refer to it as the conjugate when it's one irrational denominator. Okay, because remember, why are we saying we are rationalizing the denominator? Remember guys, the square root of 5, if you go to your calculator and you say square root of 5 and you say equal, what you see is an irrational number. What is an irrational number? An irrational number is a number which, when we express as a decimal, shows a non-recurring and non-terminating decimal. What do we mean by non-recurring? There's no repetition of numbers forever. You can see here it's 236, 067, 97, and even what you see here is not the end. There's more numbers after this last number. All right? It's just that your calculator is not infinite to accommodate all the numbers that you would see after. There are more numbers. So it's a non-terminating, does not stop. 2, non-recurring. There is no forever repetition of numbers here. So that's why we say this is an irrational number, but we rationalize the irrational number to become rational. What is a rational number, guys? A rational number is a number that can be expressed as an integer. and 5 here looked at alone is a rational number. Okay? So we've rationalized the denominator using this special one. If it was root 7, we were going to say root 7 over root 7. If the denominator was root 2, we were going to say times by root 2 over root 2. If the denominator was root 12, we were going to say times by root 12 over root 12. I hope you understand. This guides the special one that we utilize to multiply, so that at the end of the day, our denominator is not irrational but rational. That's why we call this thing rationalizing the denominator. Okay, let's go and look at another problem. Because we are blessed here, we have problems. Nice life problems. Look at this problem. 1 over 1 minus root 2. What do you see here? The numerator, the denominator. In the denominator, how many terms? 1, 2. Now you have 2 terms in the denominator, unlike this one where you had 1 term in the denominator. Okay, so how do we go about doing this one? So the first thing you need to understand is that in the denominator, we have a problem. Why? Because this is 1 minus root 2. This root 2 is an irrational number. 1 minus an irrational number still means that the denominator is irrational. We can't have an irrational number in the denominator, or at least mathematically, they always say that we need to make sure that our denominator is not irrational. So what are we going to do? We are going to rationalize the denominator for the 2 terms. How? Now we can use that word. We will apply what we refer to as what? The conjugate. Now you can say conjugate, say. All right? Now you can say conjugate. Now you can say conjugate. All right? What is a conjugate? Conjugate is simply the same terms that you see here, but with a different sign in between. That's what a conjugate is. Same terms, different signs. Same terms, different sign in between. That's what it is. Same terms, different signs in between. That is what we call a conjugate. So we are going to multiply by a special one, but this special one is a conjugate. We are going to multiply in the denominator by 1 root 2, but we are going to put a plus in between. Put brackets around that, multiply by that. But what we do in the denominator, we do in the numerator. Same thing. Then we let it rip. Monomial by a binomial in the numerator. 1 times 1 is 1. 1 times square root of 2 is square root of 2. Doesn't matter if we have a root in the numerator. Go to the denominator. We want to eliminate the root. 1 times 1, you're going to apply FOIL most. 1 times 1 is 1. 1 times positive root 2 is root 2. Then you done with 1. 1 times 1, 1. 1 times positive root 2, positive root 2. Then you move on to the negative root 2. Negative root 2 times 1, negative root 2. Then negative root 2 times positive root 2, that's negative root 2 times 2. Remember guys, the square roots are the same. So therefore the 2 and the 2 I can multiply underneath the same square root. What does that give you? 1. Now root 2 minus root 2, that gives me 0. Root 2 minus root 2, that gives me 0. Then the last term, minus square root of 4, which is obviously 1 minus 2, which gives you what? Negative 1. So what do I have there in the denominator, guys? 1 minus square root of 4, which is 1 plus root 2 over 1 minus 2, which I finally formally complete and say 1 plus root 2 over negative 1. Okay. Any questions so far? If you have, ask. If you don't, then you are fine so far. But I'm not done. I just want to check so far. Any questions? We multiply the denominator by the conjugate. What is a conjugate? A conjugate is terms that are the same as the denominator but just with a different sign in between. So this is like we are forming the reverse of a difference of two squares. The whole objective is so that we eliminate the root. It's no longer going to feature in the denominator. As you can see, no square root in the denominator. Okay. Okay, then we finish this divided by that. 1 plus root 2 divided by negative 1, that's simply going to give me negative 1 plus root 2, which I can officially formalize and say the final answer is minus 1 minus root 2. Okay, and that is that. Yeah, Bobo Loans by MB. If you were part of my WhatsApp group, then you would know when the lives are happening. And if you want to be part of my WhatsApp group, please send me a DM message so that I can share with you what are the details that pertain to being part of my WhatsApp group. You know, then you will know when I go live, because the learners that are in that WhatsApp group, they get sent the link, you know, the minute I go live, and then they can join the live session. You know, with things sprucing up for the next few lives, I will send the schedule ahead of time so that they know when to join. You know, if they can avail themselves or not. And failing which, of course, if you miss, then you can always go to my YouTube channel and watch the live lesson at your own time. Yeah. Anyways, guys, so do we see how we approach these questions? Rationalizing the denominator if we have one irrational number. What we do, the specialized one that we multiply by. Rationalizing the denominator if we have two terms, the specialized one that we use to multiply. Then, interesting thing, the algebra skills that you are applying, which you learned in grade 10. Okay. Uletloho is like, is it a must to do the whole method? What do you mean, is it a must to do the whole method? What do you mean? Like, Stooks is like, schools ain't even open. Heartbreak. Well, the thing is, schools aren't open. Some schools are open, my friend. This one is open, right? So stick around, Baba. Or like, it's long. No, remember that I am doing this so that I can explain to you what is happening, guys. Okay, I am doing this so that you know what is happening. All right, but like I said, what you can do here is you just multiply by the conjugate. All right, multiply by the conjugate from here, really here. All right, you can move straight to there, and then you can move straight to the final answer, really. Okay, yeah. Okay, you can, but remember, I am explaining to learners that obviously maybe some of you are being exposed to this the first time, and if I did not show you the steps, if I didn't show you everything that I've done, some of you would be like, "Aibosa, how did you get this? How did you get that? Or how did you get this?" Okay, or how did you get that one, or the other one, or that, you know? So yeah, guys, please, yeah, okay, yeah. So I think I'm going to have to finish this soon. All right, practice questions. Go to the homepage. I posted up practice questions there. These are practice questions. I posted them up long time ago. Okay, now look at this question, for instance. Okay. If you go to my homepage, guys, the second or third last video that is actually on my homepage here on TikTok has like some exponent and surds game challenge questions. You know, this is the paper. All right, I posted this up for your benefit. Okay, go and check them out. Okay, I posted them up for your benefit and practice, because the lesson, this one, I did it. So I wanted to give you, go and do those problems. Okay, there's more. Okay, yes, I do have a group, Son of the Most High. Like I said, DM me if you want to be part of the group, so that I can send you the information that has to do with what it entails to become part of the group. Because unfortunately, it's not a free exercise, if you know what I mean. 3 over root 3 minus 1 minus 2 over root 3. Here we are dealing with the addition or a subtraction. Of fractions. Where can you text me to receive? Being part of the WhatsApp group, these are the ways in which, you know, unfortunately are. Where can you text me? If you are part of my WhatsApp group, then you can text me like directly. So yeah, these are the dynamics. But if not, then basically you're just going to have to wait for me to go live again. So hence I was saying, if you want to be part of the WhatsApp group, DM me, then I will escalate to you the what basically, yeah, it entails to become part of that, and then I can support you. Throughout your whole entire grade 11 journey, and you can get your 95% and above for mathematics for this year, for the whole 4 terms, if you are consistent and if you continue to follow up on things. Because I have learners that are like that were part of my WhatsApp group last year, and they were joining my live lessons. They were also obviously like harassing me like crazy throughout the year, you know, about everything and anything that was mathematical that they did not understand. And some of them achieved very high marks, I must say. 95%, 95 and above, because that's our aim this year. We don't want to be performing anywhere less than this, guys. This is the cap. If you don't get 100%, we will forgive you. Your minimum can be at least 95. I will then that means at least you are human. Maybe you made errors. We'll accommodate that 95%. But if all goes well, guys, this should be the cream of the, you know, the crop of marks that we get for grade 11, because grade 11 is just that good if you are consistent for maths, please. Anyways, someone once said this is called the butterfly method. When you have 2 fractions, instead of going and finding the LCD, you can use the butterfly method. Okay, so step 1, okay, you multiply the 3 and the root 3. So at the left top corner, you get 3 root 3. Then here, you multiply -2 with root 3 minus 1. That's step number 2. Then step number 3, you multiply the denominators. So this is what they call the butterfly method. For 2 fractions that you have to add or subtract, you can do that. But unfortunately, if you don't have 2 fractions, then you have to go through the process of writing or finding the LCD. then of course, you have to take the method that basically, when you are adding fractions, you find the LCD, then you have to actually form equivalent fractions, and then get the answer from there. Yeah, so these are basically surds, how we take care of surd. Now we can check. 3 root 3, obviously, that's fine. Minus, we distribute the negative 2 inside this bracket. Okay, remember, this is 2 terms. That's why we put brackets around the multiplication of negative 2. Son of the Most High, when you are part of the WhatsApp group, you know. If not, then it means that you're just going to always have to wait and see when I go live. Hence I was saying, DM me if you want to be part of the WhatsApp group to get just like details pertaining to that. And then obviously, yeah. Then the negative 2, we distribute. Negative times a positive, we know is negative. 2 times root 3, obviously that's 2 root 3. Then we take this negative 2, we distribute it to the last term. What's negative times a negative? It's positive. 2 times 1 is 2. Those are our terms in the denominator. So now we have those terms, and I'm sure you can see there are like terms. We'll take care of it here in the denominator, guys. Here in the denominator. For now, let's leave this root 3 into root 3 minus 1. For now, and let's deal with what is in the numerator, because we might have to factorize, and you know what I mean, guys. So let's go to the top, let's add the like terms. All right, okay, this is already sort of like factorized, but there we simplified because we want to see what can be simplified further. So root 3 minus 2 root 3, for instance. What's 3 root 3 minus 2 root 3? It is going to be 1 root 3 plus the 2. Okay, 3 root 3 minus 2 root 3. These are like terms. Okay, so remember, guys, our laws that we learned about the addition of surds is that if inside the root we have the same values and it's the same root, then it means we treat it like terms. We keep the root, we add the coefficients. Here there's a 1 and there's a 1, so that means 1 plus 1 is going to be 2. So we have 2 root a. Okay, that's what we know about the addition of like roots. Okay, addition and subtraction of like roots, we call them like roots. Addition and subtraction, as long as it is the same root. Okay, I hope we are clear here. So for instance here, okay, we are going to get 1, 3 minus 2 is 1. Root 3, that's a like root. We keep the root as it is, plus 2. Okay. Then we can see here, in the denominator, there's nothing that can be done. Okay. As far as cancel, we thought maybe there's something that was going to be common and the same, but it seems like there isn't. So in the denominator, let's go distribute. Root 3 times root 3, we get 3. All right. Because remember, guys, why do we say we get 3? Root 3 times root 3, obviously we take the same root, we multiply 3 and 3 because these are the same root, we get square root of 9, which is 3. So that's why I know that root 3 times root 3 is 3. Then root 3 times negative 1 is negative root 3. But we have a problem, don't we? What is the problem in this answer? What is the problem in this answer, my good friends? What is the problem in this answer? The problem we have that we can't have. What is the problem? What is the problem, guys? Come on, I'm waiting for you to tell me what is the problem. What is the problem with this answer? Is this answer final? Can we leave it like this? Thank you. No, it's irrational. We can't have a problem. Okay, we can't have this root either there in the denominator. So we have a problem there. So what do we have to do then? Now you can use that big word you guys love using. We have to do what then? We have to multiply by the what? By the conjugate. Okay, by the conjugate. In other words, we have to rationalize the denominator. Okay, yeah, so that big word you guys love so much, conjugate. Okay, it's almost as if you guys found a new love, conjugate. Okay, so let's go. So here, now it's like we're back at grade 9. A binomial by a binomial. Hi guys, simply you should know what should be done. There at the top, what are you going to have? You are going to have 3 root 3 plus 3. Root 3 times root 3 is going to give us 3. 2 times 3 is 6 plus 2 root 3. That's what you have in the numerator. In the denominator, we're simply going to have 3 minus 3. Haha, this is beautiful. Not 3 minus 3, man, obviously. What's 3 times 3? It's 9. My mistake there. My mistake, my fault. Okay, my mistake, guys. 3 times 3 is 9, and then root 3 times root 3 will give us 3. But of course, it's 9 minus 3, because we know most that with this minus and plus, all we really care about is this 3 times 3, which is 9, and then root 3 times negative root 3, which is negative 3. Debuchotom, grade 8 learners, what about them? If you want support for the year as a grade 8 learner, send me a DM. I will send you information pertaining to grade 8s. Secondly, this TikTok page is for grade 10s, 11s, and 12s. I do have a TikTok page for grade 8s and 9s, so that's where I go live for the grade 8s and 9s, but it's only when you are part of my WhatsApp group that you will know the schedule. So I need to send you information. You then give that information to your mom and dad. They go over it. If they are saying they approve that you be part of this group, then obviously they will make the necessary contact as per the details I'll send you. Okay, so please, yeah, guys, at the end of the day, understand all of you are minors, so any communication pertaining to the WhatsApp group and being added onto that has to actually come via your folks. You can't have my number, because if you have my number, then it means you have access to my WhatsApp. No. Send me a DM on TikTok. Then I will send you the information pertaining to the WhatsApp group. Your parents need to approve, and they have to okay it and then support it, and then also say, we are going to make this financial commitment as per the requirement. Then you can be part of that. If not, then I guess then you're not going to be. So it's just like that. So let's go and add the like terms, guys, in the numerator. Final answer, 3 root 3 and 2 root 3 are like terms, so we know we are going to get what there in the numerator? 5 root 3. What's 3 plus 6? That's 9. Over, what's 9 minus 3? That is 6. Any common what? No. I think that's pretty much about it. Okay, that's pretty much about it. Ivile, how much are your classes say? DM me, please. All of these things, DM me. DM, please. DM. Have any questions about anything? DM. I will respond. All right, guys. The TikTok live lessons, joining them, obviously being here is not. No one is paying a dime for this, right? No one. Like, you are not. You are just paying for your data, and you're making sure you are here. But guys, if you want additional things like being part of my WhatsApp group, maybe you want to become part of my specialized special force group of learners where I actually do WhatsApp lessons with them privately, then that means there's additional things that are required for that. One-on-one, obviously that's different as well, all right. I just want to say that those are some of the things that are in place for this year, different from last year, because last year when I started, everything, it was free for all, free for everything. But the more time I devote into this thing, it means that obviously that's energy, that's time, that's resources, and I hope you guys understand that point. Anyways, this is the final answer, guys. I hope we are good. Unfortunately, now I have to end this live lesson, all right? But I end this live lesson saying to you, on the home page, the problems here are there, all right? So we've done all of these ones above, but we did not do this. We did that just now, okay? We did that as well. We haven't done that. So you guys can actually, these are some of the problems you can actually challenge yourself and do. Okay, additionally, there are these ones as well. All right. Okay, please, guys. Okay, we did this one because I wanted to just introduce us to the whole concept of the rationalizing of the denominator, grade 11s. And yeah, here we are, guys. Please, these are for you to do simplification. Write this in the form of that. Here we have more. There, you see. Yeah, please, guys, you can get cracking for yourself. Okay, unfortunately, I have to end the live for the grade 11s now. I hope you guys, yeah, you learned something. You learned something. So let's do this. And yeah. So those who are already in my WhatsApp group, you can do this, and then you can send me your responses privately so that I can check. You know, and as I said, those who want to be part of the WhatsApp group, you guys can DM me. I will give you the information that is attached to being part of that group if you want to. You don't have to. You know, at the end of the day, some of you, I think you are more than capable of, with the support of your teacher at school and your teacher helping you and assisting you, and with just your ingenuity. I know some of you may be part of various programs in your community that basically help with maths and science, you know. I mean, I'm a teacher myself, but more than that, I'm a teacher where I'm assisting in a program in my community that is maths and science oriented. So there's a vast amount of experience. And guys, high school, I teach all grades in high school, grade 8, 9, 10, 11, 12. All right. And it's been years that I've been teaching. So yeah, I think, we're just under 10 years. I'm coming up on 10 years being an educator officially, and I've been teaching, and even last year I was teaching grade 12. So what I'm saying is that if you want support throughout your journey so that you can get, as I said to you earlier on, guys, we can get in this range. This is the range I'm talking about. The aim 95% to 100 for maths. You see, it's a very key percentage, this one. And to be someone that consistently is able to get this term by term, my leader, it's very possible, this thing. Anyways, let me love and leave you. Thank you so much for joining in, and thank you for your participation. Thank you for everything. You guys have been great. It's been good. Live was very positive, very vibrant. Yeah, you guys really did the things. Okay, cheers. Let me see you again. Until next time.